investigate the preparation of carbon dioxide gas and look at one of its properties in particular. As always, we're going to look at safety. So goggles, lab coat for a demo, the students 2 meters, at least 6 feet away. Need chemical safety because of the vinegar and the solid baking soda. Because we're lighting the tea candles, there's fire safety, there's always some glassware safety. Make sure any matches and tapers that have been lit are doused thoroughly with water before discarding and are fully extinguished. And ensure the tea lights have cooled before putting them away. And read the rest for the discards. Materials, the tea lights, 50 mils of just regular clear distilled vinegar, 5% acetic acid, ethanoic acid, and about 50 grams of sodium bicarbonate baking soda and the other equipment that's there. For the procedure, you're going to place the sodium bicarbonate in the beaker, carefully add the vinegar, and as the thinking routine, we're going to see what's happening. We're going to observe with many of our senses, including you're going to listen always. Do you hear anything? Care, you're going to light the match and light the tea candles about 8 centimetres, 3 inches apart, whilst the reaction is taking place in the beaker, because you want to make sure that you're preparing the CO2. And then you're going to pour the gas out. Don't pour out the liquid, and pour it about 5 to 10 centimetres above the lit tea lights. And what do you see and what do you think is happening? That's our thinking routine. First one is your observations, and it says hear or smell and what's making you curious here. But think what's going on. Try and explain what you saw and what parts are going to be hard to explain. And that may be the wondering. What's making you curious, so you can write questions down about what you would like to find out and investigate. So look at the video, and whilst that's going on, complete the thinking routine. And chemically, you've got a clear liquid here, the vinegar, reacting with a white powder, and you're producing a gas. What's the appearance of the gas as well? And here's the word equation and the official chemical names for them. Pause the video so you can write a fully balanced chemical equation and even put in the physical states of each of the materials as well. So this is what you're looking at, and the CO2, one of the products, was just poured over the materials. So what is chemically happening and why are the flames extinguished? And we're just going to look at the fire triangle. 3 components. You need a fuel, you need oxygen, and you need heat. You've got a candle. There's air surrounding the burning tea lights, and as the flame is burning, you've got some heat there. So how does CO2 affect the fire triangle? Which of the 3 components is affected by the CO2? So you're pouring the gas out, none of the liquid, please. The gas is invisible, so you can't actually see where it's going, but the candles are going out, they're extinguished. And is that the property of carbon dioxide that we are investigating here? There are indeed other gases that don't support combustion, so it can't be a definitive test for CO2, but it's certainly a property of them. And here's the summary of the thinking routines, the C components, the think components, and what are you wondering? and I hope you've got a few of those questions answered too. And as always, many thanks to WIS Team Science and Grade 9 Chemistry 1 class and Miss Hager.